Hello and welcome to this video on culturing yeast. Purchasing yeast is an ongoing expense for home brewing. An average packet of yeast can range between 4 and 11 euros. These are intended for single use. There are several options for reducing, if not mitigating, this ongoing expense for the home brewer. There are three main methods of culturing yeast: plate, solid, and liquid. Plate being the standard microbiology approach to culturing. This is an agar petri dish with yeast inoculated. Next is a solid culture. Solid culturing in this case is much like a sourdough starter. And finally, there is liquid or broth culture. The first method is plating. This will require a half cup of light dried malt extract and 3 teaspoons of agar, along with up to 500 milliliters of clean, dechlorinated water. Take a liquid medium and use this as the initial yeast culture. This suspends the cells and enables a large number to grow to a healthy state. After 24 hours in this liquid environment, dip the loop into it and the next stages can be done. To produce single colonies, you streak the loop 4 times from edge to edge. The loop is then flamed after every set. You then streak the loop through these first 4 more times. Flame, and repeat for another 4 streaks. Flame, and then a final streak is made. Along this final streak, you hope to have individual colonies grow. The alternative method is a lawn. The lawn is made by flaming the loop until it is red hot, opening the yeast source and dipping the loop in. You then seal your yeast container and lift the petri dish lid off. You run the loop all over 1/3 of the dish area. You may need to do this repeatedly to cover the entirety of the area. The colonies will then grow on this 1/3 of the petri dish. The hope is that by repeatedly flaming the loop and reducing the number of viable cells on it, you can then have a clean tool with which to spread and essentially make a very thin layer of possible yeast cells that will increase to the size of a yeast colony in 24 hours. The next option is a solid culture. This can be done by adding yeast to a combination of light malt, sugar, or flour. This will provide a usable sugar substrate. Add water to this until it resembles bread dough. It will rise over the next 12 hours. In the case of a wine yeast, the water component can be substituted for apple juice, wine, or similar. Adding an equal amount of the selected sugar substrate to the yeast mass every 12 hours will eventually lead to a usable mass of yeast. This will need to be maintained in a jar or something similar in order to keep it going. Unfortunately, it requires experimentation to figure out how much is required in grams for each of the strains you culture this way. Finally, there are liquid cultures. These require a half cup of light dried malt extract or a similar sugar substrate. You will also require up to 500 milliliters of clean dechlorinated water. Add the dried malt to a clean jar. Top this up with water to 500 milliliters and replace a cap on it. Shake this up to break up any masses of your sugar substrate and ensure yeast has full access to this. This should give a specific gravity of 1.040. Microwave this on high to bring it to the boil. Then let it cool to 25 degrees centigrade. This will ensure that yeast will remain viable and be in the environment in which it grows most effectively, quickly, and with least stress. Add 1 gram of dry yeast to this. Leave it in a 20 to 22 degree environment for 24 hours. Over this time, the liquid yeast should turn quite murky and cloudy. Add this to a progressively larger jar every 24 hours with the same concentration of yeast. This will give a larger population each day that it is added to a new container. By increasing the population in each jar, or by increasing the size of the vessel in which you are growing this yeast up, you can create a very large quantity of yeast in a very short period of time. Considering these methods, there are rather obvious reasons to use one method over another, but here are several. Plate cultures are good for selecting a specific yeast strain out from a larger crowd of other strains. A means of doing this is to use a substrate such as juice to select for traits and effectively encourage genetic drift in the direction desired. However, It requires lab equipment and resources. The solid option is easy to do. It is a broad spectrum method of supporting yeast. It is also a simple matter of adding glycerol to prevent cell rupture if the specimens are frozen for storage. Liquid yeast does not affect the contents of a brew significantly. Most liquid media has used all of the substrate before it is added. Further, the yeast does not experience the same degree of osmotic shock due to a transfer from solid or plate. Osmotic shock being the process or the effect of being moved from a solid environment to a liquid environment where the cell experiences constant pressure that may crush it. Conversely, each particular type of culture has its downside. Plates are good if a sterile environment and equipment is available, and the means of processing it is available, such as a dedicated incubation chamber. Without that, it is rather difficult and rather expensive. Solid yeast strains are similarly handicapped. An example of this is the requirement to feed a solid yeast and the lack of specificity to a yeast strain. This not only increases genetic drift, as the media is not specific, but if the yeast is not fed daily, it can become bad very quickly. Finally, liquid yeast culture have the same limitations and difficulty as a solid yeast culture would. It is difficult to store and is expensive to do so. Liquid yeast media can range between $186 and $630 a bottle. As a consequence of genetic drift, there is a finite number of generations that yeast can be cultured and then further subcultured before it mutates beyond the generally accepted boundaries. And this is normally somewhere in the range of 8 to 12 generations, meaning there is a range of roughly 1 week to 10 days in which you can repeatedly subculture a yeast strain beyond the first time. Further to that, beyond this time frame, the viability of the cell line, let alone the ability to ferment and produce the product desired, becomes highly questionable and needs to be closely monitored. It may be possible to do so, as it may be a very resilient and strong strain of yeast. But again, it requires constant, careful observation and monitoring of the yeast strain. Thank you for watching this video. Please post any comments, questions, or suggestions you may have below.